In this question, we're asked, which of the following numbers is rational? Okay, and you have to understand, it really helps if you know what rational means before you try to answer this question. Rational in mathematics means it's some number divided by another number. Okay, so for example, 3/4 is rational. 1/7 is rational. The number 10 is also rational because 10 is just 10 divided by 1, right? But we don't write the divided by 1 typically. We just say 10. So these are examples of rational numbers. They're things you can write as some number divided by some other number. It's a nice fraction. Now, there are plenty of things in math that are not rational, like the number pi. Remember what pi is? Pi is 3.14159, and that's where I stopped memorizing it. But it goes on and on and on forever. And you can't write a decimal that goes on forever as a simple fraction, typically. Okay, there's some exceptions, but this is an irrational number. It doesn't fit nicely into some number divided by another number. So right away, you should see one thing we can rule out, right? Anything with pi in it is going to be irrational. There's no way anything with pi can be rational. So that's a nice one to cross out. But what about all these other ones? Well, what about the square root of 6, for example? Try putting in the square root of 6 into your calculator. Okay, I'm going to type that in here, and let's see what I get. I get 2.449489, and it goes on and on and on forever. So I'm going to guess that's not rational, because it just keeps on going forever and ever and ever. There's a couple things that do go on forever, which are rational. Let's maybe just talk about those, like the number 1/3. You know how that's just 0.33333 forever? It does go on forever, but it looks like a different kind of number, doesn't it? 0.3s forever, it's repeating. When you see a nice repeating thing that goes on forever, that's a sign of rationality. This craziness over here, numbers that look random that go on forever, that's a sign of irrationality. So if it helps, you can think about it that way. But let's keep looking at this list. Let's think about which of these numbers could be expressed as a fraction. How about 2 cubed? Well, what is that? That's, let's get back to my pen here. That's the square root of 8, which if you type that into your calculator, that's another ugly one. 2.82847, blah, 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 blah. Okay, not looking good so far. How about 5/125? Well, initially you may be looking at that like, gosh, that's even worse. That's a fraction inside a square root. And you know that the square root of 5 is not rational. If you type it into your calculator, you're going to get another one of these terrible decimals. But think about what 5/125 is. Okay, I need some space. We're going to get rid of you guys. What's 5/125? Well, that's a fraction that could be reduced. Okay, that's, if you think about what 125 is, 125 is 5 times 5 times 5. And a pair of 5s cancels out, so what you get is 1/25. Okay, so this is what we're really talking about. The square root of 5/125 is really just the square root of 1/25. And that is equal to the square root of 1 divided by the square root of 25. Now the square root of 1 is 1, you should know that. The square root of 25 is 5. Well, look at this. We just had a rational number pop out of this thing in a place it didn't really seem like it was going to. So this question is not quite so simple as it might seem. I mean, some of them were easy to rule out, right? Anything with pi in it. But the rest of them, we had to kind of massage these a little bit. Sometimes you might see fractions in here, sometimes not. Sometimes you might see the exponential answer as the rational, sometimes not. So you just have to play around and see which one of these things you can describe as a fraction, or in other words, as a rational number.